am Dr. M.Maria Julie, Assistant Professor, PG and Research, Department of Physics, St.Joseph College of Arts and Science, Cuddalore. Now I am going to talk about monostable multivibrator using op-amp. In this multivibrator, one state is permanent stable state while the other state is temporary state. The permanent stable state is high. Apply a triggering pulse to change output state to low. But this state is a temporary state, so it will remain it low state for some time, and after some time, without applying any triggering pulse, output goes back to permanent stable state, that is high stable state. Only one triggering pulse is required to come back to the permanent stable state. So frequency of output is equal to frequency of input triggering pulse, thus called as single shot or monoshot multivibrator. So this circuit produces a single pulse of specified duration in response to each external trigger signal. For such a circuit, only one stable state exists. When an external triggering is applied, the output changes its state. The new state is called as a quasi-stable state. The circuit remains in this state for a fixed interval of time. After some time, it returns back to its original stable state. In fact, an internal triggering signal is generated which drives the circuit back to its original stable state. Usually the charging and discharging of a capacitor provide this internal trigger signal. Next, circuit diagram. So in this circuit diagram, there are two Zener diode, two PN junction diode, one capacitor, 4 resistors are used. So in most of the circuit, we required only one type of pulses, either positive or negative. So one type of pulses should be eliminated. This is done with the help of diode when it is forward biased. Let us assume for above circuit, the stable state is positive saturation voltage. So diode D1 is forward biased and voltage across is 0.7 voltage. So thus voltage across capacitor, that is voltage at inverting terminal. So the voltage across capacitor is 0.7 volt. So next, select values of R1 and R2 such that voltage and non-inverting terminal is greater than 0.7 volt. So output is positive saturation voltage. So voltage across capacitor is always 0.7 volt because of diode. In forward biased, condition resistance of diode is very small. So capacitor is almost short. So no charging takes place. If output want to be negative saturation voltage, then voltage at the inverting terminal should be greater than non-inverting terminal. So apply a negative triggering pulse at non-inverting terminal to change the output state. So next, operation of the circuit. To understand the operation of the circuit, let us assume that the output V0 is at positive saturation voltage, that is in its stable state. The diode D1 conducts and the voltage across the capacitor gets clamped to the 0.7 volt. The voltage at the non-inverting terminal is controlled by voltage divider circuit of R1 and R2. Voltage at the non-inverting terminal V2 is equal to beta V0. So here beta is equal to R2 by R1 plus R2. If threshold voltage, a negative trigger of amplitude Vt is applied to the non-inverting terminal so that the effective voltage at this terminal is less than 0.7 volt. Then the output of the op-amp changes its state from to positive saturation voltage. The diode is now reverse biased and the capacitor starts charging exponentially to saturation voltage through resistance. The voltage at the non-inverting terminal is now negative beta saturation voltage. When the capacitor voltage becomes just slightly more negative than negative beta saturation voltage, the output of the op-amp changing its state back to positive saturation voltage. So the capacitor now starts charging towards positive saturation voltage through resistance until capacitor voltage reaches 0.7 volt as capacitor gets clamped to the voltage. Here clamped means a device, usually of some rigid material, for strengthening or supporting objects or fastening them together. An appliance with opposite sides or parts that may be adjusted or brought closer together to hold or compress something. Next, let us derive the expression for pulse width. Initial voltage at t is equal to 0 across capacitor Vc0 is equal to Vd1. So here role of supply voltage will play output voltage. Vs is equal to V0 is equal to minus saturation voltage. Voltage across capacitor at time t is given by the equation below. Vc into t is equal to Vd1 exponential minus t by Rc plus V0 into 1 minus exponential minus t by Rc at time t is equal to t. So V0 is equal to minus saturation voltage. So Vc into t is equal to minus beta saturation voltage. Vc into t is equal to Vd1 minus V0 exponential minus t by Rc plus V0 minus beta saturation voltage is equal to V diode 1 plus saturation voltage into exponential minus t by Rc minus saturation voltage. T is equal to Rc by 1 minus beta logarithmic of 1 plus diode 1 voltage by saturation voltage. So beta is equal to R2 by R1 plus R2. If B saturation greater than diode 1 voltage and R1 is equal to R2. So finally we get the time period value of this circuit is T is equal to 0.69 Rc. Thank you.